Hey guys, I know this looks bad, all right? But guess what? We're gonna make it not look so bad, okay? So we've got these, we are solving rational equations, right? I've got variables in the denominator. It's a little intimidating, but guess what? We're gonna work with it. First of all, these big old fractions are like, what? I don't even want to deal with that. Well, guess what? We are going to use a strategy to actually get rid of all the fractions. You heard me right, okay? So we're not solving this, it's just an example, okay? I don't like that big fraction, right? So one strategy is to actually get rid of the fraction by multiplying both sides by 5, okay? As long as I multiply both sides, I'm good. My equation stays true, right? And when I do that, these 5s cancel. This becomes a 50, and then I'm solving this, which, I mean, is still a big equation, but I don't have a massive fraction, right? So we're doing something similar to that, but it's like, these are a lot more complicated than just a 5, right? So we need to figure out what we multiply by to get rid of those, okay? So what we need to find is called our LCD, our least common denominator, okay? And you're like, oh, that sounds familiar, right? So when we add or subtract fractions, right? If I have 1/2 plus 1/3, I have to figure out the least common denominator, right? In this case, it would be 6, right? So we multiplied 2 times 3 and got 6, right? Now, that's not always going to be your LCD, just multiplying them together. Sometimes it'll be something less than that, but that does work often, okay? So my very first step here is I'm actually going to factor anything I can. Over here, we're all factored, but I'm going to factor this guy really fast, okay? So when I factor this, I'm going to end up with x minus 5 times x minus 7. Now, if you need a factoring review, you're like, what on earth did you just do? I'll link a video for you in the corner, okay? But I'm feeling good here. I'm like, okay, I'm seeing similarities here, right? This is feeling good. So my least common denominator between all three of these is going to be x minus 5 times x minus 7, okay? So watch what happens when I multiply both sides by this, okay? I'm going to use a different color. So I'm going to multiply everything by x minus 5 times x minus 7, okay? So we're multiplying this side, x minus 5 times x minus 7. And then I'm multiplying this side, okay? Keeping in mind, I'm multiplying both of these, right? So I'm really distributing it in and multiplying them both, okay? So I'm multiplying this guy by x minus 5 times x minus 7, and this guy, x minus 5 times x minus 7. Okay? Now watch what happens. This is the exciting part, okay? So when I multiply this, guess what? X minus 7 and x minus 7 cancel. So I'm just left with 4x times x minus 5. Oh my gosh, that's not as scary, right? Plus, okay, this guy and this guy are going to cancel, and I'm left with 3 times x minus 7. Oh my gosh, best day ever, okay? Look what happens here, guys. X minus 5 and x minus 5 cancel, and the x minus 7s cancel. What? So I'm just left with minus 6. What? You're like, is that even real? We just got rid of all denominators. It is real. Okay, now what we're going to do is we're going to distribute. Okay, I'm distributing that 4x in. So I end up with 4x squared minus 20x. Okay, and then I'm going to distribute this guy in. So I get plus 3x minus 21 equals negative 6. Okay, this is looking like I can handle this, right? I'm going to combine like terms, so my x's. So I get 4x squared minus 17x minus 21 equals negative 6. Now my whole goal here is to know what x equals, right? So usually I would be trying to get x alone, but right now I have an x squared and an x, right? And it's kind of hard to get them alone when they're like that. So what we're going to do is get everything on one side, get it equal to 0, and then see if we can factor it, okay? So I'm going to add 6 to both sides. So I have 4x squared minus 17x minus 15 equals 0. Okay, now I'm going to see if this can factor. Okay, and it can. I'm just going to write what the factors are. But again, I will link a factoring video if you need one, especially because this is a little different because it has a 4 out front, right? So I will link a different video as well if you need it. But this is going to factor down to 4x plus 3 times x minus 5. And that is equal to 0. Okay, so now I can set each of those parentheses equal to 0, right? So I have 4x plus 3 equals 0. And x minus 5 equals 0. Okay, so when I solve those down, I end up with x equals negative 3/4 and x equals 5. Okay, I know you want to be done, but we have to do one more thing. Okay, we have to check for what are called extraneous solutions. Okay, whenever we have a problem and we started with a bunch of x's in our denominator, right? We have to make sure none of these answers will make it so we end up with a 0 in the denominator, because we don't even deal with those, right? We don't. So I can go ahead and plug these in. So negative 3/4 minus 7, that's not going to give me a 0, right? Negative 3/4 minus 5, that's not going to give me 0. And then this guy was just those two multiplied together, so I know it's not going to give me a 0, right? Now 5 minus 7, that's going to give me a negative 2, so we're good. 5 minus 5 is going to give me a 0, okay? If I plug in 5, I'm going to end up with 3 over 0, which is not okay. So guess what? This guy is not actually a solution. Even though algebraically it came out as a solution, it's what we call an extraneous solution, okay? So if you were to turn it in to your teacher with x minus 5 as an answer, sorry, you'd probably get docked because it's not actually an answer, okay? So I end up with one answer, which is x equals negative 3/4. Okay. All right. I hope this made sense. If you need some more examples, I'll link a playlist for you. Thanks.